Saraswati Sisukunj Bhagwala Borsad, Standard 8, Subject Science, Chapter number 13, Sound, and this is your second video. In last class, we have seen that how human produce sound, right, or sound produced by humans. So we discussed that we have voice box in our throat. There are two vocal cords which is stretched across the voice box in a such a way that leaves a slit in between, right, that leaves slit in between. And when you breathe out air, the air passes from that slit and vibrates the vocal cords. So this is how sound get produced. But you will think that why in men the sound is different and why in women sound is different. So look, the sound quality, it depends on the thickness of vocal cords. If vocal cords are more stretched and the vocal cords are thin, so sound will be different. If vocal cords are not stretched much, if it is loose, right, and the vocal cords are thick, then sound quality will be different. This vocal cords in all human beings is surrounded by muscles which makes them, or we can say which stretch them, right, and create different sounds. So I hope you understand that how human produce sound. Now today's topic is sound needs medium for propagation. Now medium means you can take any kind of thing, like here solid, liquid or gas, right? Sound needs this three medium, means any substance it can be, right? But these three things in any form it requires for sound propagation. It means sound cannot propagate in vacuum or in space, we can say. Outside of the earth there is no sound propagation, right? Sound cannot heard. Okay, if we talk about that two humans are on the moon, so they cannot talk with each other, right, because there is no atmosphere. Same thing, it is connected with the explosion which happens on the sun. We cannot hear those explosions. Why? Because there is vacuum in between sun and the earth. Sun is so far away out from the earth, right, and between there is space, there is no atmosphere, right? And when you are on the earth there is atmosphere, and that is a medium of air. It can be different medium. You had done that activity, means in type of a game that one friend is keeping ear on the bench and other friend is playing tabla on it, so you can heard it more louder. If you will compare, your ear is not attached or it is not in contact with the bench, right? So you will hear it lower, right? So that is the loudness of the sound. Now here, if we want to compare the loudness, let's compare the molecules which is here in solid, liquid and gas. So here in solid, as you know that molecules are together, right? Molecules are closer to each other compared to the liquid. If we talk about liquid, and if we talk about gas, right? So this is how the molecule structure of any solid, liquid or gas. Somehow it is like this. Okay, so if we compare this solid, liquid and gas, so sound is so little bit faster here in solid, right? It becomes slower, or we can say loudness is more in the solid. Here it decreases and here it is more decreases, right? Now you will surprise that why it is like that. Now see here, these molecules are closer to each other. First molecule will vibrate and immediately, look, the closer one will vibrate, and so on. The all molecules are getting started vibrating, right, together, or we can say very quickly. If we talk about liquid, right, their molecules are so far away from each other. So first will vibrate, then it will take a little bit time to get vibrate the second one and the third one. So sound will take a little bit more time, right, to be on the other side or other end, right? Here in gas, right, it is more far away than each other, so it will take a little bit more time. But in real situation, if you want to get this idea, it is so much difficult to get that, right? Because in day-to-day life we are speaking, another person who is just opposite side, they can heard us so quickly, right? So the time is taken, which is so small that it is so much difficult to measure. Now you will ask me that why sound cannot propagate or heard in the vacuum? Because there is no material present in the vacuum. Vacuum means it is empty space. Even there is no air, there is no any kind of gas, liquid or solid. That is called vacuum or space. There is no any material present, right? That is why it is like this, that it can be only propagate, it can be only heard when the medium is present, like solid, liquid or gas. I hope you understand that sound needs a medium for propagation. Okay, so our next topic is we hear sound through our ears, right? We hear sound through our ears. So as you have studied in 5th standard chapter sense organs, right, that how our ear works, same kind of explanation is given here, right? There are two parts of ear, that is outer ear and inner ear, right? Outer ear is like a funnel, right, or cone shape, and there is a canal, right? Funnel also has some canal like part, right? So this outer part will collect the sound, right, and it will move into the canal like structure. That canal like structure end at very thin membrane which is called eardrum. With the sound, that eardrum will vibrate, right, and from there those vibration will move into the internal, or we can say inner ear, right? And there are many nerves which is connected with your brain, and those nerves will carry those vibration in a form of message to your brain, and this is how we can hear, right? And this whole process, collecting the sound passes, eardrum vibrates, the message is carried through the nerves to your brain. So this thing happens in very short time, means in microsecond this thing happen. It doesn't take much time, right? So I hope you understand that how we can hear, right? Three things you have to keep in your mind: the structure, or that how our ear looks, funnel like structure, right? This collect the sound, it moves in a canal, it will vibrate the eardrum which is at the end of the canal, right? Those vibration will move into the inner ear. From there that message or those vibration is carried by the nerves to your brain, and this is how we can hear. Okay, let's move to the next point. Okay, so now our next topic is so much important. Look here, amplitude, time period and frequency of vibration, right? Before that, one thing is so much important, that is oscillatory motion. Now in previous standards you have studied about oscillatory motion when you are studying about the motions of an object, right? Different motions are there. Okay, so in that you have studied oscillatory motion, right? Now with the oscillatory motion you have also studied about the time period, that what is the time period. Here we are going to learn about amplitude, time period in a little bit connected with the sound, and frequency of vibration. Now about amplitude, in my first video if you have seen the definition, that maximum displacement of vibrating body from its mean position, that is called amplitude, right? Again, maximum displacement of vibrating body from its mean position, right? It's called its amplitude. Right now here you will say that here right now you are talking about vibration, you are connecting oscillatory motion. So vibrating is the same with oscillatory motion. Vibrations are oscillatory motion of object, right? So that is why they are connected, oscillatory motion and vibrations. Okay, so as you understand the amplitude, let's talk about time period. So time period is a time taken by vibrating body to complete one oscillation. Time taken by vibrating body to complete one oscillation. Let's talk about one oscillation, that what is the one oscillation. If you understand that here there is one pendulum, right, and it takes 2 seconds to oscillate, or we can say to reach to the maximum amplitude and come again to the mean position, means the starting point. It takes 2 seconds, so that is its time period, right? That is its time period. I hope you understand, right? Like this is the pendulum's mean position, it goes here, right, then here, and then again come back to the mean position. So that is one oscillation, right? Or you can say it starts from here, you are taking the pendulum here right now, right, like it is here, it goes there and come back again to the right side. So that is its one oscillation, right? Okay, if we talk about humans, right, that we are vibrating. Okay, so if you are moving from your place to some city, and when you come back again, right? So whatever time you took, that is your time period for maximum displacement. Now let's go for the frequency. Frequency means number of oscillation in 1 second by vibrating body. Now look, time period and frequency, don't mix it up. Frequency is different and time period is different. Frequency means in 1 second number of oscillation. Keywords I am giving you. Frequency means 1 second number of oscillation. Now here second means time is fixed. 1 second number of oscillation in frequency. Time period means oscillation is fixed. One oscillation, now time we need to find out, right? So don't confuse. Now here see, time period. Time period. Now time period means total time to complete one oscillation. Complete one oscillation. Right, total time required to complete one oscillation. Now here, if you want to write, so we can write here total time upon number of oscillation. So it becomes its formula, right? When there is a vibrating body given to you, that total time is 20 seconds and number of oscillation is 40, right? And find out the time period. So we can find out time to complete one oscillation for the particular vibrating body, right? Okay, so now let's try to find out the unit. Now look here, total time, we are finding time here. So what is the unit of time? That is second, right? So you will write that unit is second. Unit is second, right? And it is written as this S, right, as a symbol. Okay, now let's talk about frequency. Frequency means number of oscillation. What we are trying to find out? Number of oscillation. So it will be number of oscillation in unit time. Now here we'll write in 1 second. Unit time means 1 second. Right? Number of oscillations in 1 second. So here what we are finding? Number of oscillation. Here you can write per second too, in 1 second, or number of oscillation per second. So here how we'll write number of oscillation per time, right? Number of oscillation per time, right? So this is formula for both. For frequency this is the formula, for time period this is the formula. Now unit for this frequency is hertz, right? Unit for frequency is hertz. Okay, now you just observe this. Here total time is in the numerator, here time is in denominator, here number of oscillation is in the denominator, here number of oscillation is in the numerator. So we can say they are inverse of each other, right? They are inverse of each other. So important thing I am writing here. Important thing. What is important thing? You can say T is equal to, T is time period, is equal to 1 upon F, 1 upon frequency. Time period is reverse, or we can say it is inverse of frequency. Same for frequency. Frequency is also inverse of time. It means that when time period is given for some vibrating body, you can find out frequency. When only frequency is given for any vibrating body, you can find out the time period, right? But if there is no time period, there is no frequency, so there will be number of oscillation and time taken for that number of oscillation will be there for some example. There are 1 or 2 examples are there in the chapter. We will try to solve it. Before that, just take a look. So let's take one example here. A simple pendulum make 10 oscillation in 20 seconds. You can see here, right, that a simple pendulum make 10 oscillation in 20 seconds, we have to find out frequency and also we have to find out time period, right? So how we can find that two things? Let's see here. First one, number of oscillation you need to write. Number of oscillation is 10 oscillation and time period. Time period is 20 seconds, we can say. Okay, now first one, for time period. Time period is equal to total time upon number of oscillations, right? Total time upon number of oscillations, that is your formula for the to find the time period. Now here total time is 20 seconds, we'll write 20 seconds here, and number of oscillation is 10. Number of oscillation is 10. So 20 and 10, you can write easily here, that is 2 seconds, right? Time period is 2 seconds. We can say that, look here, for total oscillation 10 and time is 20 seconds. For one oscillation it took 2 seconds. For one oscillation means from the mean position to the maximum displacement, and for coming back to the mean position, for that it requires 2 second time period. Okay, let's try to find out frequency now. Frequency is equal to reverse number of oscillation upon time. Okay, so what is number of oscillation here? That is 10 upon time is 20, right? Again it is 1 by 2. What it is? 1 by 2. Here we can say 0.5 hertz. 0.5 hertz. Now observe this. 1 by 2 is inverse of 2. 2 is inverse of 1 by 2. So here we can say that time period and frequency both are inverse of each other. I hope you understand that what I want to say you. Let's take a look. Here, now let's talk about the loudness of sound. You have observed that some vibrating bodies or some objects are there which produce loud sound and some doesn't, right? So what is the thing behind that? So loudness is exactly, proportional to the amplitude, or we can say square of the amplitude, right? Loudness is proportional to the square of amplitude. Don't get surprised. Let me give you an example that if amplitude is increased by twice, right? If amplitude of any vibrating object or vibrating body which produces sound, it increases by twice, right? So loudness will increase by fourth number of it, or fourth power, we can say. If the amplitude becomes 3, so loudness becomes 9. 3 multiplied by 3, that is 9 here. And if you talk about the example of 2, that is 2 multiplied by 2, that is 4. So this is how the loudness depends on the amplitude. Now this loudness, to measure the loudness, we have unit that is called decibel, right? There are different sound measurements which is given here in the table, like normal breathing, that is 10 decibel, normal conversation, that is 60 decibel, sound of traffic, that is 70 decibel, right? An average factory, any average factory produce 80 decibel sound. Now that 80 decibel, it is actually physically painful. 80 decibel sound is physically painful, right? So it produces noise, we can say, right? That is sound, but also we can say it is noise when it goes more than 80 decibel, right? It is really painful, right? Unpleasant sound, we can say. And you have heard and you have observed many times from the factories that it produces so much sound. Okay, so now let's talk about pitch of the sound. Now this pitch of the sound is connected with the frequency. If frequency is high, means number of oscillation per second. What is that? Pitch is connected with the frequency. What is frequency? Number of oscillations. If more number of oscillation means high pitch sound. Frequency is more, pitch is high. If frequency is low, number of oscillation is low, so this pitch becomes low, right? Or there are two kind of sound you have heard, right? There is a high pitch and low pitch sound, right? So there are many examples. Let me tell that here. if we talk about this, right, so there are number of oscillations are more. If we talk about this, so number of oscillation is less. I need to explain it by waves, right? So here these are the sound waves of one object and this is the sound wave of other object. So this number of oscillation, this indicate the oscillation. There is one vibrating body and other one, these are the sound waves to understand the pitch. Here you can see less frequency means number of oscillations are low, right? And here more frequency because number of oscillations are more. So this type of thing create high sound or high pitch sound, right? I am not talking about loudness, I am talking about high pitch sound. Okay, now here if we talk about this object, it produce low pitch sound. Okay, let's take example of a drum and a whistle. Have you seen the drum, right? And you have seen whistle too. Have you seen one small stone like thing which is present in the whistle, right? And what we are doing in the whistle, we blow air into that whistle and that stone vibrates, right? Very quickly it vibrates. Within 1 second it vibrates many times. What about the drum? We are just using the stick to make the vibration of that membrane. Now just think, which thing will vibrate more, that small stone or that membrane of the drum? Yes, you are correct, that small stone will vibrate more times compared to the drum. So which thing will produce more, or we can say high pitch sound? Whistle. So whistle sound, we can say it is high pitch sound and a drum sound is a low pitch sound. I hope you understand the pitch concept. Okay, so now let's talk about audible sound and inaudible sound, right? Audible sound means which we can hear and inaudible sound means which we cannot hear. Now if we talk about human body, it cannot hear 20 hertz sound. 20 hertz sounds means oscillation, 20 oscillation per second. If any body is vibrating 20 times in a second, if any body is vibrating 20 times in a second, we cannot hear that, right? Okay, we cannot hear the sound which is more than 20,000. Or at 20,000 hertz, we cannot hear this 20,000 hertz sound. 20,000 hertz means a body which vibrating more than 20,000 times. A body which vibrate more than 20,000 times. So between this, all sound we can hear, right? Between these two, all sound we can hear. So this is the frequency of human hearing, right? This is the range in between human can hear. Okay, if we talk about this 20,000 hertz, right? There are many instruments which produce this sound. If you have heard about ultrasound frequencies, ultrasound actually those waves vibrate more than 20,000 times, right? So that is ultrasound, right? If we talk about some animals like dogs, they can hear this more than 20,000 hertz frequency, they can hear. So police use that kind of whistles which produce more than 20,000 hertz frequency, but human cannot hear, right? You can play it, right? You can produce it, but you cannot hear. It will be blank, nothing, right? Okay, so this is the frequency. 20 hertz, less than 20 hertz also we cannot hear. I hope you understand the frequency range of 20 hertz to 20,000 hertz. So let's talk about now noise and music. Now this is really easy concept to understand. Noise means that is unpleasant sound, right? And music means the sound or the vibrations which you enjoy, right? On which you love to dance, right? In marriages. So that is music. The music or those kind of vibrations which you are enjoying, right? Which you feels happy with that is music. Unpleasant means which you don't like to hear. Sometimes many people cover their ear by hands, so that is unpleasant sound. We can take example of horns of scooter together or horns of vehicles together, factories, right? Many students are talking in the class together, so that is also unpleasant sound, that is noise, right? Unnecessary sound also we can compare noise with that is unnecessary sound. From here there will be a new concept of noise pollution. Right, so what is this noise pollution? That is, we can say that unwanted sound, right? That is noise, and when it getting increased, so that becomes pollution, right? So we can say firecracker sound and traffic sound, and many people are shouting, and factory sounds and machinery sounds. This all are known as noise pollution. We can say loudspeaker sound, DJ, right? When you are increasing volume of your television, you play music with the loud sound, that all causes noise pollution. Now you will say, sir, now don't do that, we love to hear the loud sound. But because of those loud sounds, many people get some health problems, right? Many people are suffering right now, right? Like they are not getting proper sleep. The first thing, that lack of sleep, hypertension, right? Or we can say their blood pressure get increased by hearing the loud sound. Anxiety, they will suffer. And if those people are being continuously in the contact with loud sound, because they are like working in the factory with the machines which produce the loud sound, by some time period they can lose their ability to hear, right? So that is some health problem which is connected with the noise pollution. So it is need to be decreased. This noise pollution concept you have already studied in primary, like 4th and 5th standard. So how we can decrease this noise pollution? So we can say that we can use the silence devices which can reduce the pollution or reduce the sound in factories, right? Silencer, as we are using in the motorbike, right? And in cars, that is also silencer, that is silence device which is decreasing the sound of machine. It also be included in the factories. Okay, what we need to do, we need to plant trees around the roads, right, in the both side of the road, so which will also absorb the sound waves, right, and it will decrease its frequency, right? And that is why we can say that the sound pollution can be decreased. The factories which are there, or if there is a new factory, so those factories should be away from the residential area, right? It should be not closer to the residential area, because people are living there, right? So those sound will harm them. If we talk about music systems and television, so we should play it very slowly in the low volume, right? So you can hear, not we don't want to spread that noise pollution. Okay, if we talk about horn, so we should use that horn when it is necessary, right? Many people are using horn continuously when you are on their bike, right? So that thing should be decreased. So these are the things that we can this is how we can control the noise pollution. I hope you understand whole chapter, right? If you have any doubt, you can ask me during the live class. I will try to solve your problems. Thank you so much.